So we're on the third axiom here of exposure in photography, the first being aperture, the second being shutter speed, and this last one being sensitivity, and it's film plane sensitivity. Um, I use the term film plane. A lot of people don't understand what that means. The film plane is where light is recorded within your camera, okay? And it's designated on most cameras, on your higher end cameras, with this little icon with a circle with a line through it. That means that at that point, if you look right down on top of your camera, that's the point where focus is actually pulled to clarity, okay, in your camera. And that's probably on this camera, that's where the pickup chip is located. If this were a film camera, it's where the film plane is located. You and I have two film planes. Our optic nerves within our eyes are film planes. I've been joking for a long time. I think one of these years I'm actually going to do that, of actually having that film plane symbol tattooed right at my temple, right where my optic nerve would be. Just a small one. You'd have to look kind of closely to see where it's at. But anyway, where light is recorded, that's the film plane. And the sensitivity of that film plane will go through and determine what the rest of our exposure will be in terms of shutter and aperture. Now, back in the days of emulsion, film came in a lot of different types of different sensitivities, from 25 ASA, which was made by a Fujichrome. It was a slide film, an extraordinary, beautiful slide film, Velvia, if I remember, all the way up to a 1600 ASA by Kodak. It was a color film, not a color reversal film. And that would give us a range. Anyway, so we go 25, then 50 to 100. See a pattern here. 100, 200, 400, 800, and 1600. So we have a doubling of that sensitivity, which would trade off to one stop. Here's an answer to one of your pre-test questions. Okay, the difference between 4.0 and 5.6 is the same as, after the through, is the same as a 100 ASA to a 200 ASA. So the more sensitive the film is, the more light sensitive it is, it buys us another stop. It buys us a little bit more speed in being able to go through and capture that. Well, if you're shooting film, hats off to you, okay? And there seems to be a bit of a trend going back to shooting on emulsion, and I hope that catches on. I would like to put my old film cameras back to work again. But honestly, I can't deny the convenience of having this little piece of technology embedded in my camera obscura. This is a pickup chip. I think this is a full frame one that acts the same way as emulsion does, but it does this digitally and does this with pixels. And those pixels, the more the merrier you have in pixels, the more thousands you have, the crisper, the less noise is induced into your frame. Well, this has a sensitivity as well. And the more we up the sensitivity, then the grainier that image becomes. And it's called noise. It's called a signal to noise ratio that we get into. If you've ever closed your eyes, if you've been in a dark room and your pupils have dilated to the point where they've allowed in as much light as humanly possible, and when your rods and cones in your eye go through and take over, your brain can go through and start to see noise. Okay, it's grainy. It's that granularity as you try to look around and see what's going on with that. Well, it's a physics principle that deals with light and the absence of light. So I talked about different shutter speeds. These are shutter speeds incorporated in a digital camera: 100, 125, 160, 200, 250, and so on. You see the doubling of that as it goes. But there are some in digital photography. We have some increments in between that help us go through and finesse perhaps exactly the right type of shutter speed that we need to get into. My Fujichrome goes up to, I think, 32,000 ASA. I can't remember what it's at. I have it handy right here. Let me take a look and see what it'll go to. 400 up to, here, popping in the background, 64,000, 12,800 ASA is my highest. I've never shot it at that high. I've never needed to, because all the rest of the ISO settings have allowed an adequate light. But on your camera, this is probably what you're looking at, from 100 up to 1600 ASA, or maybe a little higher than that. The problem then with this, like I was kind of intimating in the slide before, is the more light sensitive we go, the noisier the image becomes. So you see here within this, on the Empire State Building, it's clear on the left, having been shot at a lower ISO. If we upped the ISO on the right, then you see that that graininess start to settle in. Maybe this will go through and illustrate that even better as you look at this image from left to right, as we go from a low ISO up to a high ISO setting, and how that induces noise. These days, though, I saw a study on the latest GoPro in terms of its noise and signal ratio, and uh, it's pretty amazing, I have to say, to look at the quality of a real high ISO setting within the GoPro as opposed to a low one. To the untrained eye, the difference is negligible. It's tough to go through and see how it's going through and really just upsetting the image in terms of its clarity that way. So the idea is the lower the ASA ISO setting, the better your picture is going to be. But these days, we're in situations we're shooting without a flash or without a whole lot of light. We can bump our ISO setting up to where we're able to actually get a good exposure with some good depth of field and call it news there. So I hope you've enjoyed these little clips on the trivium of exposure. Go back and watch them if you still don't understand that. And let's get you up to date. Go out and start shooting. That's the main thing, okay? See you later.